Let us now discuss the second case, that is when the image is formed is virtual image. Okay, look at this ray diagram. Again, XPY is the convex refracting surface. I have shaded this convex refracting surface just to indicate that it is a denser medium. Let's say its refractive index is mu2. Now this denser medium, it is placed in a rarer medium having refractive index mu1. Okay. O here is the object. It is a point object. Now when this point object is placed relatively close to the concave refracting surface, when it is placed quite close to the concave refracting surface, so that the distance u is lesser than the radius of curvature, then in that case what will happen? This ray of light, this incident ray OA, will go like this. Of course it will bend towards the normal. You see, instead of going straight, now let me just show you using a ruler. I have this kind of a ruler, so just have a look here. Instead of this ray of light going straight, it bends now. Do you see? Something like, just look at this diagram here, just look at this line here. This ray of light, it should be going like this, is it not? It should be going like this, but then since it is traveling from rarer to denser medium, instead of going this way, it bends towards the normal. Understand? But then it cannot bend so much. It bends, okay, but it cannot bend so much so that it touches the principal axis. That happens why? Because the object here is too close. So you see there's another ray of light that goes in that direction, that goes in this direction, and these two rays, when you produce in the forward direction, they will never meet. Okay, they will never meet. Why? Because they diverge away, right? They will meet only when you produce in the backward direction. So when you produce in the backward direction, they seem to be forming an image at this point I. So such an image which is formed by producing the rays backward, that image is a virtual image. Is that clear here? Okay. Now OA is the incident ray. C here is the center of curvature. If you join C and this point A, then like I said, this angle will be 90 degree, yes or no? So this dotted line will be the normal. OA, angle of incident ray, AN, normal, so the angle between them is I, the angle of incidence. Where is the refracted ray? This is the refracted ray. Refracted ray and the normal, the angle between them is the angle of refraction R. Understand? We drop a perpendicular from A to the principal axis. We call this perpendicular as AM. And then again, object is always the first. We name the angle as alpha. Second is always the image. We name the angle as beta. And lastly is the center of curvature. We name the angle as gamma. Always remember object, image, center of curvature in all the diagrams. Okay? Object will be alpha, image will be beta, and center of curvature will be gamma. If you is instead, let's say you write here gamma and instead you write here beta, then in that case everything will be different. Okay, you will make a mistake. Now the distance from the object to the pole, the distance is u, object distance. From the image to the pole, that is the image distance v, and from the pole to the center of curvature, that is the radius of curvature r. Okay, so again here let us apply the Snell's law. By Snell's law, we have what? We have, can you guess, mu1 sine I again. Mu1 sine I is equal to mu2 sine R. So this implies mu1 I is equal to mu2 R. I will not tell you how I'm getting this from sine I, how I'm getting I, from sine R, how I'm getting R. I'm not going to explain that anymore. That have already been explained in the previous lecture. Okay. Alright. Now we need to find the value of I and R. Now how do we find the value of I? Just look here. Let me write Control Z, this one. Let me. Okay, just look at this diagram. Look at this diagram here. Something like this. This diagram, this point is A, this is O, and this is C. So if you look at this angle here is angle I, this is alpha, and this one is gamma. So from here what do we get? We get I is equal to alpha plus gamma. No? Then again look at this triangle AIC. In triangle AIC, this is angle R, this is angle beta, this point is I, this is A, and this is C, this is angle gamma. So from here we get R is equal to beta plus gamma. Is that clear? So in this equation we write mu1, instead of I we write 1 alpha plus gamma. Mu2, instead of R we write beta plus gamma. Understand? Let us not name this equation only. This part is not necessary. Okay, let's call this sum equation 1. Okay, right, next layer. Okay, so this implies 1. This implies mu1, what was it? Mu1 alpha plus gamma. So again, instead of alpha I will write tan alpha plus tan gamma. This will be beta plus gamma. So instead of beta I write tan beta plus tan gamma. Again, I don't need to explain to you why I'm getting this equation. Okay, that has already been explained nicely in the first lecture. Okay, now what is tan alpha? Tan alpha is this one, perpendicular by base. So there'll be AM by OM. AM by OM plus tan gamma. Tan gamma, this is gamma here, so there'll be AM by MC. AM by MC. Mu2 tan beta. Tan beta, beta is this, so there'll be AM by MI. AM by MI plus tan gamma is AM by MC. What do I do next? I cancel AM, 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 and I multiply mu1 inside. So I get mu1 by OM plus mu1 by MC is equal to mu2 by MI plus mu2 by MC. Let's call this sum equation. We already used equation 1, this will be equation 2. But what is OM? OM, this is nearly equal to OM, that is nearly equal to OP. OP. But what is the value of OP? OP is U, plus or minus U. It is on the left side, so that will be minus U. Minus U. What is MC? MC, that will be equal, nearly equal to PC. MC, that will be nearly equal to PC, and that will be plus R. Plus R. And what is MI? MI, that is nearly equal to PI. PI, PI, and that is minus V. minus v. So therefore, putting all these quantities in equation 2, you get mu1 by om, that is minus u, plus mu1 by mc, mu1 by r is equal to mu2 by mi is minus v, plus mu2 by mc is r. Again, what I do, I take this to the left side and I take this part to the right side. So I get if I take this to the, this is minus, if I take it to the, it'll be plus, so that you get mu2 by v minus mu1 by u is equal to, take this to the others, it will be mu2 by r minus mu1 by r. Therefore, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. This is the required expression. Okay, so if you look at this expression, it's exactly the same as when the image formed is real, right? It will be the same. Why it will be the same? Because the direction of the light is the same. In that case also, light is still going from rarer to denser medium. Understand? We will do the second case, the different case in which light is going from denser to rarer, and in that case you will see there is a difference. Okay, so again, this is another important derivation. Practice this nicely, and this complete ray diagram has to be understood when you draw. If you don't understand, you watch the video again and again until you understand. Okay, the physics has to be very clear to you, why this light is bending like this, why it is going like that, and why it is before it is going, it is bending till here, and now it cannot bend in here. Why? I told you, because this only if this point object is quite close to the convex refracting surface. Understand? So why this is forming virtual image? All these questions you have to ask whenever you study. Whenever you study, you don't just by heart the diagram, you have to understand the physics behind it also, because when you understood, then that is when you will make less mistakes. Okay, if you by heart, you may forget, but once you understood and you by heart, then you remember nicely. All right, practice this nicely. This used to come in the exam.